Hey, sixth grade. So I'm going to do a small lesson for you to review energy transformations and then also go over your assignment for today in case you don't join the Zoom or need a little reminder. So first off, you should have already done your bell ringer, and I'll go over that tomorrow in your next video, just so you don't watch this first and get your answer. So we're going to go over your bell ringer tomorrow. And we're going to go over energy transformations, how to identify what energy its object starts with, and then what energy it turns into. So your objective or your essential question today is, how do we identify energy transformation taking place around us? So energy transformations are everywhere. Okay, they are in your room, they're in your home, they're in your body, they're everywhere. So first we got to know, what is energy? There we go. Okay, so energy is the stuff that makes stuff do stuff. Okay, so energy is the I don't know, the stuff that makes you do stuff. Okay, so that's the things that cause things to happen. Okay, so it's the ability to do work, and work is force times distance. So the first thing you need to remember is that the law of conservation of energy, and that says that energy cannot be created or destroyed. It is only transformed from one form to another. So energy can't be created like that, and it cannot be destroyed to where it doesn't no longer exists. So, in other words, when you have a form of energy, if you have something else, it's because it transformed into it. It didn't just come up one thing and then disappear, and then come up another thing and disappear. It went from one to the other. Okay, so example, like lighting a match, you have that chemical energy that it starts with, and then it turns into heat and radiant energy. So there's two types of energy, like we've gone over before. There's potential energy and kinetic energy. So potential energy is energy due to the height of the object, or stored energy. So this object is not necessarily moving, but it has the potential to move. It has the potential to turn into another type of energy. And the higher that object is, the more energy it's going to have. So, like books on top of a desk, or if you're something on top of a mountain, um, something on top of a slide, or water at the top of a waterfall would have potential energy, as then once it falls, it would have kinetic energy. So kinetic energy is energy in the form of motion. The faster the object is, the higher the kinetic energy. So the book's falling, skiing down that mountain you were on, sliding down the slide you were on, or the water going over the fall, that would be kinetic energy because they're all moving. So then you have other types of forms of energy within potential and kinetic energy. So mechanical energy is a type of kinetic energy. Heat and thermal energy is a type of kinetic energy. Chemical energy is a type of potential energy. Electrical is a type of kinetic. Electromagnetic and nuclear are all types of energy, but they're within the potential and kinetic energy. Okay, so mechanical energy is energy of motion or position. So not 100% efficient because a lot is lost to heat. So when you move, heat is produced, and so a lot of that energy, some of that energy turns into heat energy and not just movement energy. Electrical energy is moving electrical charges, so electricity from batteries, power lines, lightning. So if you plug anything into a wall, that's electrical energy. Radiant energy, energy that moves in waves. This is going to be like your light energy, your microwaves, radio waves. So this is all radiant energy. Heat and thermal energy is, of course, energy that produces heat. It's measured by your temperature. This is a kinetic energy because the particles are moving. So the hotter an object is, the particles that are made up, the atoms that are making up that object are moving faster and faster. And so it's a movement energy because those particles or those atoms are moving. And nuclear energy. This is a potential energy. This is energy that's stored inside the nucleus of an atom. once those atoms break, and it's really hard to make those atoms break, but once they do, like in the sun, um, they release a lot of energy. So it's going to be stored energy. These are the most powerful types of potential energy because they store a lot of energy within that nuclear. Okay, and then chemical energy is energy stored, so that means it's potential energy by chemical bonds in an object. So like food, gasoline, wood, fire, those things are chemical energy because those chemical bonds within those are storing energy, and then again, once you break them, it creates more energy. So let's try the windmill. So the windmill is, remember we talked about wind energy. Those windmills are those tall towers that have propellers on the top. So those move. When they move, they create energy. So you got to think about what is creating that energy, and the movement is creating that energy. So the movement energy is called mechanical energy. And then you got to think about, okay, well, what's next? What does that movement energy do? And windmills turn that mechanical energy into electricity, which is going to be electric energy. So mechanical wind energy. Oh, this didn't go all the way to energy, but yes, it turns from mechanical wind into turning the blades. That's also mechanical, but it does turn into electrical energy. Okay, a flashlight is going to be chemical and electric because of the batteries, and it turns into radiant or light, and then thermal, also heat, because the flashlight turns a little warm. A microwave, you have to plug it in. So anything you have to plug in starts with electrical energy, and then it turns into radiant because it usually a microwave lights up, mechanical because of the sound or sound energy, and then thermal, of course, because the microwave heats up our food. Firecrackers. So firecrackers have those chemicals inside. So it starts with chemical energy, then you light it up, and it turns into thermal energy because you don't want to touch a firecracker; they're hot. Radiant energy, they light up, and then mechanical or sound energy because, of course, they make a sound. Okay, bicycle. So they're talking about you being on a bicycle. So first off, you have to have energy inside your body. So that's going to be chemical energy is from the cells in your body. Then your mechanical energy is you pedaling the bike. And then, of course, the bike is moving, so it's also mechanical energy. Okay. So hopefully this is a good reminder of what energy transformations are. Your assignment today is to click on this link. I want you to play 2 games to review energy transformations and then take the quiz. So the link will take you here. There's games on this side here. You can also press the show all, and it'll show you all the games it has. I want you to play at least 2 to practice. Um, I'm taking you on your word with that you're practicing energy transformation and not going straight to the quiz. But I do want you to do 2 of those, and then what I want you to do is do the quiz. Once you're done with that quiz, I want you to see, does it? Oh, here's the quiz. I'm sorry. Here's the quiz. I want you to do the quiz. You'll press start and take it. Once you're done with that, I want you to take a screenshot of your score and then attach it to your assignment and turn it in. If you need help attaching or taking a screenshot, please let me know because I don't want you to lose points on this just because you didn't know how. There is also tutorials or videos on how to do those things in Google Classroom. So make sure you watch this video. Your assignment is to go to this website, play 2 of these games, and then do the quiz. Take a screenshot of your quiz score and attach it to your assignment, and then you can turn it in. Make sure you've done your do now in your notebook, and make sure you've done your exit ticket in your notebook. Alrighty. If you are in class, you'll have your bell ringer sheet printed, so make sure you've done that. And then also, if you have any questions, if you're in class, let me know.